Hello everyone, welcome to Gradeup. This is the live session on Theory of Machines and Vibrations Super Quiz 1 discussion. Okay, you know we have started the concept of super quizzes. You have solved, you have done the super quiz of thermodynamics, okay, basic applied, and now we are into the super quiz of Theory of Machines and Vibrations. Okay, so you have been solving the super quiz 1 of Theory of Machines and Vibrations for the past 2-3 days, and we have got a very good response from all of you. Over 600 students and users have solved this quiz, okay, and I think that that's a good number, okay, keeping in view the preparation that you are doing for the GATE examination. Okay, so super quiz, you know the concept. We give you 12 questions and then you solve those questions and your marks and your all India ranking appears into that, so that you come to know that what your preparations are going at what level. And then we are here to discuss the your queries, your doubts, and then I will be sharing some of the important tips and tricks and strategies related to those questions, or specifically those topics which I have been or which have been included in the syllabus of the Super Quiz 1. Okay, so I think there are some people coming. Yes, Samadhan Salunke is saying hi. Yes, very good evening to all of you. Please get enrolled into this session. Okay, get involved. You can give your comments. Hello everyone, how are you all doing? Okay, we will start very shortly. Hello Muruga Prabhu. Yes, hello Muruga Prabhu. I hope you all are doing really good. Shall we begin? Okay, am I audible to everyone? Okay, yes, shall we begin? Okay, I think that we should start solving the questions. There should be some number of people who should join us so that the interaction could be really good. Good evening, sir. Yes, good evening, Samadhan. Yes, yes, I think we should start now. Okay, meanwhile, you can ask your queries in the session, but please ask the sessions only, or ask the questions, ask the comments only about these topics. Okay, any other topic related to any other subject or any other topic, we will take it up after in some another video. Okay, we will have a live session for it, another one. Okay, so yes, now the people are growing. Okay, now we should begin it. Okay, so this is the live session on Theory of Machines and Vibrations Super Quiz 1 discussion. Okay, so we shall begin with the first question. What is the first question? But first of all, before giving the questions, let me give you some basic analysis of this test, what we have seen so far. The number of attempts has been 600. This data is still 445. Okay, almost 20-25 minutes before. The maximum marks you obtained were 20. It is a 20 marks paper and you obtained 20 marks. Out of those, 4-5 users got 20 marks. The average marks scored in this paper was 4.6. okay, 4.6 was the average marks. The lowest marks was somehow less. It was only minus 5.28. But please, those who got in this range, please do not get disheartened. It's just the starting phase of your preparation. Still you have 3-4 months left for your preparation. You have to be boosted up. You have to have good confidence. Do not let your confidence get shattered. You will surely get good marks, and in the good range you will surely slowly, gradually you will move up in the range and you will get surely good marks. So people who got less marks, less than the average or less the negative marks, maybe some of you have got, maybe there could be some reasons that why you got such low marks. But please, this is my personal request that do not get disheartened. This is just an early phase of your preparation. Slowly and gradually you will rise up. Okay, so take that as my view, as my point, and just do not get disheartened and continue your preparation with full enthusiasm. So this is basically the analysis of the questions that we have seen. There were 12 questions in this test, and there are some questions like question number 1, question number 5, question number 7 and question number 9 specifically, in which some students faced problems, because this is the correct attempt percentage. This shows that how many students or how many users who attempted this test got the questions correct. Means this first question only 40% of the users got correct. Likewise, this ninth question only 29 or 30% users got correct. That shows that these questions were a bit difficult. Okay. As and when I will discuss these questions, you may come to know that what is the problem, that why you didn't understand or why you attempted it wrong or why you got this question as wrong. Okay. So no problem, there may be some questions, or there are some questions in a real examination also, like the gate examination and all, which are a bit difficult, but you need to understand that what is the difficulty, where is the problem lying, that whether you are not able to understand the question properly, or you understood it but you could not attempt it, or you even attempted it very clear, means you attempted it correctly but somehow in marking the question, the option, you marked it wrong, or if it was an NAT question, you gave the wrong input by mistake or somehow. So you will see that what could be the problem. I will also tell you that what problem you could have faced. Okay. Salman Ali saying good evening sir, good evening Salman. Varun Chenna, good evening Varun. So I think that now we should start our discussion with each and every question. So let us begin with question number 1. Okay, this is the new question of simple mechanism. This is a question of 1 marks. Okay, first of all we will read each and every question, we will understand it, what we need to do, and then we will move on to its solution. Okay, so the first question says, observe the mechanism that is shown below. Which link must be fixed to get the drag link mechanism? Let me tell you, the catch of this question lies in this word, that is the drag link mechanism. I think that many of you have got this question wrong because of this term, the drag link mechanism. Otherwise this question was very easy. This was a simple question of a simple mechanisms of a 4-bar mechanism. The 4 lengths have been given, AB, BC, CD and AD. Okay, but the drag link mechanism created a bit of a problem. So the drag link mechanism means, let me tell you, please focus, the drag link mechanism is nothing but a double rocker mechanism. Okay, or a crank mechanism, double rocker mechanism or a crank mechanism. Simple, this is very simple. Okay, this is very simple. Double rocker or a crank mechanism. Now you can see that the double rocker or a crank mechanism, for the double rocker or a crank mechanism, the shortest link must be fixed. So in this case the shortest link is the BC link, so this link must be fixed in order to get a drag link mechanism or a double rocker or a crank mechanism. Sorry, this is not double rocker. Oh, I made a mistake. This is not a double rocker, this is a double crank mechanism. Okay, double crank or a crank mechanism. Okay, so the answer is option C, that C should be fixed. In the solution it is given that BC should be a frame, and the frame or the fixed is one thing only. So do not get confused with the solution that has been provided in the quiz. It is same thing, it is a drag link mechanism, the BC link should be fixed. Any other names for other mechanisms also? I use Sachan. No, there are no such other names for the other mechanisms. Please, this was the only link which has the other name of the drag link mechanism. Other, you know, it's a double crank, that is crank, or you have seen the crank rocker mechanism, or crank lever mechanism is one of another name for the crank rocker mechanism. So this was a very simple question containing 1 marks. So let us move forward with the second question. The second question again is a very simple question. Okay, Simple mechanisms, again 1 marks question. Okay, in this, match list 1 and list 2 and select the correct answer using the codes given below the list. The list 1 shows 4-bar chain, Grubler criterion, Scotch-York mechanism and pantograph. Okay, then the list 2 says simple harmonic motion, Grashof linkage, enlargement and degree of freedom. So now you should know that 4-bar chain links with the Grashof linkage. The 4-bar chain links with the Grashof linkage. The Grubler criterion is used for degree of freedom. Okay, so this goes with 2, this goes with 4. The Scotch-York mechanism is the mechanism, it is an inversion of a double slider crank mechanism, and the double slider crank mechanism, Scotch-York mechanism, gives you simple harmonic motion. Simple harmonic motion, so this goes off with 1. And the pantograph is used for enlargement of any figure. If there is any figure, the pantograph is a device which is used for the enlargement of that figure. So pantograph goes for 3. So A goes for 2, B goes for 4, C goes for 1 and D goes for 3. So the correct option in this is option number B. Okay, this is very clear. If you have any problems regarding the questions or regarding the topics that I am discussing, you can ask them in the comments. Okay, then one more question. This is again a new question of simple mechanisms, 1 marks. In an elliptical trammel, which point surely does a circular motion? Okay, it is a very simple question. If you just know what is an elliptical trammel, you can surely solve this question without any problem. Okay, in an elliptical trammel is somewhat like this. Okay, these are the 2 links and this is the elliptical. These are the 2 links like this, and this is the link that is joining the 2 blocks. And if this is the link about which we are talking, which point surely does, this is the midpoint of the link, this is the midpoint of the link that does the circular motion. Any other point other than the midpoint of this link connecting the 2 blocks or connecting these 2 links does a elliptical motion. You should also know this, that other points does the elliptical motion. Only the center point or the midpoint of that link does the circular motion. Okay, again very simple question. Okay, next, move on forward. But before moving on forward, let me tell you that we have launched a new channel exclusively for GATE preparation, a new YouTube channel on which you are right now watching this live session. It's my humble request to please subscribe to this channel so that you can get new awesome videos like this in the future. And by subscribing, you will never miss any updates. Please press the bell icon so that any notification of any video that is posted on that channel does not get missed by you. Okay, and also about the free live online free video course that we have launched a few days back is also available. The link for which is given in the description box below. You can go there, you can get enrolled and keep learning and keep preparing yourself for the GATE 2019 examination. Okay, so let us move forward with another question. This question is a previous year GATE question of GATE 2003. The topic is velocity analysis of simple mechanism, 1 marks question. Okay, what is that? First of all, let us read a question. A circular disc shown in its plane view in the figure rotates in a plane parallel to the horizontal plane about the point O at a uniform angular velocity omega. Okay, and two other points A and B are located on the line OZ at distances RA and RB from O respectively. Okay, so I think there might be some bit of difficulty in this question because the figure was not given, but if the figure was given, then this question would have been a cakewalk for anyone. Because the figure was not given, so some of you might have faced a bit of a problem, but simply drawing the figure was the only task that you need to do in this. Otherwise, this question was very simple. So let me draw the figure. Okay, Jayesh Patil is saying, yes sir, subscription done. Okay, thank you Jayesh, this will be very helpful for you. Okay, so let us move forward. Let me draw the figure and then you can check in your own solution where you have done this question that whether you drew the figure correct or not, or if there was any problem in understanding the figure, that also you can check it out. Okay, so a circular disc, first of all draw a circular disc. Then what it is saying, suppose there is any point O. It is not saying that O is the center, so we will draw it a general point O like this. Okay, this is point O. This disk is rotating about this point with an angular velocity of omega. This is also given. Then there are two other points A and B located on the line OZ. Suppose draw a random line, a straight line randomly like this, Z. OZ is the line. Then there are 2 points, that is A and B on this line, and they are at a distance of, this is a distance RA, and this is the distance of the point B, that is RB. Okay, this is only what is given. Then what we need to find out, we need to find out the velocity. Okay, we need to find out the velocity of this link AB. Okay, this is, what will it be? See, if this A point is rotating about omega, you will get it as omega into OA, omega into OA. Okay, sorry for this interruption. Okay, omega into OA. Then for the B link, this will be omega into OB. But if we see for the between A and B, it will be omega into OA, OB minus OA. Okay, and omega OB is equal to, what is OB? OB is equal to RB minus RA, and the direction will be same as the direction of motion of point B, because if the point B is rotating in this direction, then this will also be rotated in the same direction as the sense of B. So the correct answer for this question is option C. You have to please see that the option B, C and D look similar by these things, that is omega RB minus RA, RB minus RA, omega RB minus RA. The only thing you need to focus here is about the direction, and in this the direction is saying it is opposite, it is same, and the direction is from O to Z. This is very much wrong. Only the confusion arises between these 2 points, but the direction is same as the direction of motion of the point B. Okay, any problem in this question? Anyone? Any problem? So shall we move forward? Okay, let us move forward into the next question. Question number 5. What does this question say? Please focus on this question. This is a bit not complicated, but a bit numerical problem and a bit lengthy also. So please focus on this, that what does this question say. This is again a new question of simple mechanism, 2 marks. Okay, Samir Khan says no problem. Okay, let us move forward. This shows a quick return mechanism is shown. Okay, the value of alpha will be in degrees. Okay, this is the angle alpha that is given. A stroke is given as 60 centimeter and the length of slotted bar is given as 50 centimeter. Okay, so first of all, let us write what are the things that we have. We have been given a stroke equal to how much? 60 centimeter. And what is a stroke? A stroke in this case is PP dash, and this is also equal to D. This is also equal to a stroke. A stroke sorry for this. Sorry for this interruption, please. Please, this is some bit technical issue that has been we are looking upon to it. We will resume soon. Please be patient, please. Okay, so let us begin again. This question we were doing, sorry for the technical issue that we had. Okay, really sorry for it. Okay, so this I was telling you, the stroke is given by PP dash is equal to DD dash, that is equal to 60, it is given. Okay, and the length of the slotted bar, that is OD is equal to, what is given OD as length of slotted bar? 50 centimeter. Okay, then what we need to see, triangle AOB is similar to triangle MOD. Okay, so angle AOB will be equal to angle MOD. So in triangle, if we see in triangle AOB, what we see, tan of angle AOB is equal to what? Then we will use this, that is MD upon OD. Okay, so what is MD? What is MD? MD is equal to half of the stroke, that is equal to 30 upon 50. So this you get as 0.6, and on solving you will get this angle AOB as equal to tan inverse of 0.6, tan inverse of 0.6, that you will get as 30.9637 degrees. This is angle AOB, this one. Then for finding this angle, that is angle OAB, angle OAB will be equal to what? This angle is already 90, so the sum of these two angles is equal to 90. So this angle will be 90 minus 30.9637, which is equal to 59.0362 degrees. Okay, so we have got this angle. Then alpha will be equal to what? 360 minus twice of this angle. So alpha will be equal to 360 minus twice of this angle, that is 59 point this, and on solving you will get the value of alpha as 241.928 degrees. This is again a very simple question. Just you need to apply this concept, that the concept of similar triangle, and then you can very easily solve this question. Okay, next let us move ahead with the next question, question number 6. This is again a new question of the acceleration analysis of simple mechanism, 2 marks. Okay, Samir Khan is saying 241. Yes, Samir, absolutely, your answer is absolutely correct. Okay, there was not a bit difficulty in that question. Just the thing that you need to apply was the concept of similar triangles. Okay, now see the next question. What does the next question says? For what value of omega the absolute acceleration on slider A, at this instant will be parallel to OA. Okay, OA. See, again there is a bit of a technical issue that has been going on. I am really sorry for that. We will resume soon. Please be patient. Okay. Till then, Raghavendran is also saying 241. Yes, that answer is 241. Okay. So let me check what is this issue going on. Okay. Let me see. Okay. Okay. See the question. Thank you for being patient. There has been some technical issues that are going on. I am really sorry for that. Let us see the 6th question. For what value of omega the absolute acceleration on slider A at this instant will be parallel to OA? See, in this question, this is omega. If it is not clearly visible, please, I am really sorry for that. This is omega. Okay, this we need to find out. Okay, then this is alpha, that is the angular acceleration has been given as 10 radian per second square, and then there is a velocity of the slider that is given as 2 meter per second. Okay, so what we need to find out? We need to find out the value of omega for which the absolute acceleration on this slider will be parallel to OA. This is the link OA. Okay. See, what we do first, we see that what all accelerations does act on this link. See, this is the link O, this is the link A, point O and A. See, first of all, because of this omega, there will be a acceleration, that is the radial acceleration acting towards the center, that will be omega square into OA. Okay, the first thing is that. Next, there will be a tangential acceleration that will be acting due to this alpha, and that will be acting along the direction of alpha. So alpha is clockwise, so that will also act clockwise like this, that is alpha into OA. Okay. Next, because of this omega and the velocity of the slider, there will be one more component of acceleration that is known as the Coriolis component of acceleration. Okay, and along which direction will it act? Let me again show it to you. See, I told you during the lectures also, if any one of you have seen that, you might be knowing how to find the direction of the Coriolis component of the acceleration. But if any one of you haven't seen that, then for them I am again showing you. There is a simple procedure. What you need to do, just take your right hand, curl the fingers in the direction of omega. Omega is clockwise, so curl your finger and the thumb will point towards the omega vector. So the omega vector is like this, just straight away from you. Okay, then in that direction keep your fingers and roll your fingers towards the direction of velocity of the slider. Like this it was. Just put it like this and roll it like this. Okay, so you roll your fingers like this, so this thumb will give you the direction of Coriolis component. So in this case, the Coriolis component will act this way, that is a Coriolis acceleration, and you know its magnitude is equal to 2 into the velocity of slider into omega. That is very much simple. Now in the question it is saying that our absolute acceleration on the slider should be parallel to OA. Then when the absolute acceleration on the slider will be parallel to OA? When this component and this component cancels out each other, then only. Otherwise, if there is some component remaining from these two, then what will happen? There will be some acceleration either towards this way or this way. But that should not happen, because the question is saying it should be parallel to OA. So for that, this component and this component should be same. Okay, so how? So how that we will get? We will get that when this Coriolis acceleration is equal to the tangential acceleration, and for that 2 Vs omega is equal to omega alpha into OA. Now just supply the values. 2 into velocity of slider is 2, omega we need to find out. Alpha is equal to 10 and is equal to again there is a bit of a technical issue, please, I am really sorry. there's a bit of a technical issue that we are looking forward into it, and we will resolve it really soon. Please wait, please be patient, we are looking into it. Okay, please be patient. So this will be, okay, so we are back again. Please, really sorry for that interruption. This is equal to 2 into 2 into omega, and that is equal to 10 into the value of OA is equal to what? This is given as 4 ammeter. So this is 4. So this becomes 40 and this becomes 4. So this gets cancelled. So omega is equal to 10 radian per second. Okay. Omega is equal to 10 radian per second. So the answer is option number B. Okay. So please subscribe to our new channel for YouTube, in the YouTube that is exclusively for GATE, and please press the bell icon to never miss any updates. Okay. So let us move forward with the next question. Question number 7. Question asked in GATE 2005. Okay. The question is of velocity and acceleration analysis of simple mechanism, 2 marks question in the quiz. Okay. So the question says the time variation of the position of a particle in rectilinear motion is given by x is equal to 2t cube plus t square plus 2t, and if n is the velocity and a the acceleration of the particle is in consistent units, the motion started with. The motion started with means that t is equal to 0. It is given that x is equal to 2t cube plus t square plus 2t. So velocity is equal to dx by dt, you know that, and this is equal to given as n. So this will be 6t square plus 2t plus 2. At t equal to 0, this becomes, the n becomes equal to 2, because supplying the value of t and t0 here, it becomes 2, and the acceleration that is given as a is equal to d2x by dt square, so which is equal to 12t plus 2, and at t equal to 0, a becomes equal to 2. So a is also equal to 2 and n is also equal to 2. The answer is option number D. Let us move with next question. Any problems in this? Okay, so let us move forward. Next question. GATE 2016 question, kinematic analysis of a single slider crank mechanism. Again, a 2 marks problem. Okay. A slider crank mechanism with a crank radius 200 mm and connecting rod length 800 mm is shown. The crank is rotating at 600 rpm in the counterclockwise direction. In the configuration shown, the crank makes an angle 90 degree with the sliding direction of the slider, and a force of 5 kilonewton is acting on the slider. So neglecting the inertia forces, the turning moment on the crank in kilonewton meter is. Okay, I think the figure has been missing in this. Okay, so the figure was given in your quiz. So the figure you already know, it was like this. Okay, so this is crank radius 200, this is 800. Okay, and this is rotating at 600 rpm in the counterclockwise direction, 600 rpm. Okay, so this makes an angle of 90 degree. Okay, and this angle you already know, it is equal to beta. So R is equal to what? 200. L is equal to what? 800. So we get the obligatory ratio N is equal to L by R, which is equal to 800 by 200, that is 4. Then we know that sine beta is equal to sine theta by N, and sine theta is this angle, sine of 90 degrees is 1, so this is 1 by 4. On solving this, we get beta is equal to sine inverse of 1 by 4, and we get that value as equal to 14.477 degrees. Okay, 14.477 degrees. And the thrust force, we need to find out the thrust force first. Thrust force is given by F by cos beta into sine theta plus beta. Theta is equal to 90 degree, beta is equal to 14.47. So this again becomes sine theta plus beta, that is 90 plus beta will become cos beta. So this and this terms get cancelled. So this becomes F, and the F is equal to 5 kilonewton. So this becomes 5 kilonewton. This becomes 5 kilonewton, and the torque or the turning moment is T is Ft into R, which is equal to 5 into 200 into 10 to the power minus 3. Why we are doing this? Because it is given in meters. It is given in millimeters. So to convert it in meters, we need to do this. Okay. So this will be equal to what? 1 kilonewton meter. The answer is 1 kilonewton meter for this torque or the turning moment. Okay. So the next question, the question number 9th. Let us see what does it says. A slider crank mechanism is shown in the figure. At some instant, the crank angle is 45 degree and a force of 40 Newton is acting towards the left on the slider. The length of the crank is 30, means this length is 30, and the connecting rod is 70. Okay, ignoring the effect of gravity, friction and inertial forces, the magnitude of the crankshaft torque, that is again that thing only, crankshaft torque again means the turning moment in Newton meters needed to keep the mechanism in equilibrium is, and that is also asked correct up to 2 decimal places. Okay, so this is 30, this is 70. This angle has been given to you as 45 degree, and this angle you know is beta. So this length will be common to both. So we get 30 sine 45 degree is equal to 70 sine beta. On solving this, we get beta as equal to 17.64 degrees. First of all, 17.64 degrees is the value of beta. Then we know that Fc cos beta is equal to F, that is equal to 40. So beta we already know. So from here we can find the value of F. Again, there is some issue that has been going on. Oh, this session has been full of technical issues. I am really sorry for that. Please cooperate with us, have patience, we will resolve. Till then, you can see the question, how to solve it. Okay, this is again a very easy question of GATE 2018. Okay, so how to solve this? Okay, let me check the issue. We are working on it. Please be patient. Okay. Okay, so we resume again. Sorry for that technical issue. Okay, beta value you already got as 17.64 degrees. So we know that Fc cos beta is equal to F, that is equal to given to you as 40, and so from here we can find the value of FC as 40 upon cos of 17.64, which is equal to, you will get that value as 41.9737 Newton. Okay, but it's my request to all of you that do not round off this value here. We are taking the 4 decimal places here, and please do not round it off here. Why? Because it is asked up to 2 decimal places, so you need to do not round it off here and just keep it till the 4 values. Okay, 4 units. Then we need to find the value of Ft again, and Ft is again, you know, the same formula, that is Fc sine theta plus beta. The value of theta is 45 degree, beta you have already found out. On solving this, you will get the value as 37.2785 newtons. Okay, and T is equal to Ft into R. Ft is this and R is equal to what? 30 mm. So Ft into 30 by 1000 divided by 1000. Why? Because it should be in, this is given in mm, so convert it into meters, and you will get this value as 1.118 Newton meters, and then you need to round it off to 2 correct decimal places, so this will be equal to 1.12 Newton meters. Okay, this is right. Okay, let us move forward. 10th question, gate new question, kinematic analysis, 2 marks. Okay, slider crank mechanism is rotating with an angular velocity of 20 radian per second, having a crank angle of 60 degree with the positive x-axis of the slider direction. If the length of the coupler or the connecting rod is 100 mm and the radius of the crank is 20 mm, to find the angular velocity of the coupler in radian per second. Okay, in this it is given R, that is the crank radius, as 20 mm and the length L as 100 mm. So obliquity ratio will be equal to L by R, that is equal to 5, and omega has been given to you as 20 radian per second. So what we need to find out, and theta is given to you as 60 degree. So what you need to find out, we need to find out the angular velocity of the connecting rod, that is given by omega cos theta by n. So omega cos 60 degree divided by n is 5. On solving this, you will get this value as equal to 2 radian per second. Okay, 2 radians per second. Very simple question. Move forward. Next question, gate 2014. A slider crank mechanism with a crank radius of 60 mm and connecting rod length 240 mm is shown in the figure. The crank is rotating with a uniform angular speed of 10 radians per second counterclockwise. For the given configuration, the speed in meter per second of the slider is. Okay, so using the Kennedy theorem, we take the fixed length as 1, this length as 2, this length as 3, and the slider as 4. Okay, so this will be simply I12, this will be I23, this will be I34, and I14 will lie along this line, that is I14 along this line. So by the Kennedy theorem, omega 1 I12 I23 is equal to omega 3 I13 I23. Okay, omega 1 has given to you as 10 into 60 equal to omega 3 we need to find out into this value is 240. Both the sides it is in mm, so no need to convert it into meters. Okay, we get the omega 3 as equal to 2.5 radians per second. Then V4 by L3, or the length of this, is given to you as omega 3. So V4 we need to find out. V4 is equal to L3 is the length of the link 3, that is 240 divided by 1000, because it is given in mm, into 2.5. Again, this pen is creating a bit of an issues. I am really sorry for this interruptions that are coming very frequently now. I think that this session has been full of technical issues, okay? But we have to look upon this in the future so that you do not get that kind of a disturbance. Okay, so let me check what is this going on. You will get just simply multiply this value by 2.5 and you will get the answer as we are really sorry for this. We are working (240 divided by 1000 into 2.5), we get this value as equal to 0.6 meter per second. So this is the answer, option A. The last question, okay, the last question, see, we need to find out the number of degrees of freedom of the linkage shown in the figure. In this case, you can see there are how many links? This is the one is the fixed link, this is another link, 2, this whole link is 3, this is a ternary link, this is again a ternary link, 4, 5 and 6. So L is equal to 6. The number of joints is equal to number of joints is equal to 7 in this case. You can see this is 1, this is 2, 3, 4, 5, 6 and 7. Higher pairs are 0 and this is equal to 0. Then applying the Kurzbach equation, 3 into L minus 1, 3 into L minus 1 minus 2j minus h minus fr, and this is equal to 0. So 3 into 6 minus 1 minus 2 into 7. So this becomes 3 into 5 minus 14. So this becomes 15 minus 14 equal to 1. The correct option is option number C. The session has been full of technical issues. I am really sorry for that. But these are all the questions that we did. And there are some key points to focus that I need to tell you about all this. The simple mechanisms, you need to focus on the types of links and joints, very important. Degree of freedom concept, the Kurzbach equation, Grashof law for the 4-bar mechanisms and all its inversions. In the velocity analysis, the important thing to remember to focus is the I-center method and the Kennedy theorem. Then in the acceleration analysis, most of the questions are asked from the Coriolis acceleration, that is again very important. And for the kinematic analysis, the velocity and acceleration of the moving parts, it can be the slider or it can be the connecting rod. Both are very important. Then for the dynamic analysis, the various force determination, that is also very much important. So the next super quiz of Super Quiz 2 will be live soon, and then we will meet after 2 to 3 days for the live session on Super Quiz 3, Super Quiz 2 on theory of machines and vibrations. We have a new YouTube channel that you can subscribe, and you can get all the videos that will be free of course. And we also have the new YouTube free gate course for 2019 that you can enroll, and the link for which is given in the description box. Okay, so we will see you in the next session. Till then, thank you, bye.